All right, in this video we're going to take a look at multiplying and dividing rational expressions. Our area models will come in places because we'll need to do some factoring, some multiplying of polynomials. But to get at an understanding of how this works, we're going to look at some familiar problems like just multiplying fractions. And when I look at this first multiplying fractions problem, I know that I can just do numerators times numerators over denominators times denominators, but these are going to be big numbers. So one thing that I can do is start to split that up a little bit, and I can say, well, 48 is 6 times 8, and 6 is 2 times 3, and 8 is 2 times 2 times 2. So that's the same thing as 48. 54 is 6 times 9, there's 6, and 9 is a couple more 3's. And I'm going to multiply that by 45, which is 9 times 5. So there's 9 times 5, and 80 is 8 times 10, and so there's 8, and there is 10. And when I have it in this form, then I can start canceling some things that would make a 1 anyway. 2 divided by 2 here is 1. 3 divided by 3 is 1. This 3 divided by 3 is 1. This 3 divided by 3 is 1. This 5 divided by 5 is 1. This 2 divided by 2 is 1. That 2 divided by 2 is 1. That 2 divided by 2 is 1. And all I have left now in the numerator is a 1, and the denominator is a 2. So I was able to multiply those together without having to know what 48 times 45 or 54 times 80 is. This is a pattern that we're going to use when we deal with our rational functions. On the division side of things, I know that when I'm dividing by that fraction, I have to multiply by the reciprocal. So I'm going to start out the same way with the 42/15 and write that as a 6 times 7, and 15 is 3 times 5. And now this is going to be times. I'll flip that over. I've got the 6 there, which is a 2 times 3, and the 28 is 4 times 7. And so I can come back in again. 3 divided by 3 is 1. 7 divided by 7 is 1. 2 divided by 2 is 1. 2 divided by 2 is 1. And all I'm left with is a 3/5. Okay, so that's how it works with the fractions. Now, we'll see that happening as we go through our rational functions as well. We're going to start out pretty easy, though. In this case, the first thing I'm always going to try to do is see if there's a way by factoring that I can break these things apart. In this case, all of these pieces that are in here are already factored as far as they can go. They're all linear. There are no greatest common factors in them. So all I need to do is do numerators times numerators and denominators times denominators. So my numerator has got an x minus 7 and a 2x plus 3. So that's a 2x squared minus 14x plus 3x minus 21. That gives me a 2x squared minus 11x minus 21 in the numerator. And in the denominator, I've got an x plus 2 and an x minus 4. There's x squared plus 2x minus 4x minus 8. So my denominator has an x squared minus 2x minus 8. Now the other thing I usually have to do in a problem like this is there are some values of x that I'm not allowed to have. Those are the values of x that would cause me to divide by 0. So I have to include in here that x plus 2 cannot equal 0, and x minus 4 cannot equal 0. So that means x cannot equal negative 2, and x cannot equal positive 4. So these pieces together, the final answer of those multiplied together, along with some mention of the numbers that you are not allowed to use, that's what my answer should look like. All right, in this next problem, we have a little bit more that is going on, not a lot. I'm going to treat these things, again, they're all linear pieces, so they are all their own pieces, and if I'm going to do any of that canceling that I did before, it all has to be written in terms of multiplication. So that's why I want everything factored. And so when I write it like this, so that it looks factored, the x plus 4 times the 3x plus 1 over 2x minus 3 times x plus 4, I can see that I have an identical pieces in the numerator and the denominator. So those x plus 4s can cancel, and it will just leave me with a 3x plus 1 in the numerator and a 2x minus 3 in the denominator. Now, I've got to come back. I still have to have this domain part of the thing, the numbers that I'm not allowed to use. If I go to the place where I had the most stuff that was in my denominator, even the stuff that got canceled, I have to say that the 2x minus 3 would not be able to be 0, and the x plus 4 cannot be 0. So the 2x cannot be equal to 3, and the x cannot be equal to 3 halves, and the x cannot be equal to negative 4. So I have my 3x plus 1 over 2x plus 3 there, along with the information that x cannot equal 3 halves, and x cannot equal negative 4. That is my complete answer for that problem. All right, so now we're going to kind of double complicate things. We're going to throw some polynomials in here that are not in their lowest terms, and we're going to throw division in. So the first thing we have to do is factor those polynomials. So if I'm going to, I'll use the blue here to factor the 2x squared minus 3x minus 14. So the 2x squared goes there. The minus 14 goes there. I need a 2x and an x. These are going to add up to negative 3. So I believe if I put a 7 there and a 2 there, I'm going to get a 4x and a 7x. And if I make that negative, that'll make that negative. That'll make that part negative. The diagonals will add up like I need them to. And so my numerator should look like a 2x minus 7 times an x plus 2. And then I will factor the denominator here in green. And that starts with a 3x squared there. I got a minus 8 right there. So I'll need a 3x and an x. The diagonals are supposed to add up to a positive 10x. And a 4 and a 2. If I put the 4 there and the 2 there, I would get a 6x there and a 4x here, but that's not going to work because I need to get a negative 8. So let's try that again. I've got my 3x squared and my minus 8. These have to add up to positive 10x. And so a 3 times, well, let's see, I've got a 3x and an x. A 3 times 4 would give me a 12 and a 2 there. So that'd be a 2x and a 12x. If I make that a 2, and I need to subtract the 2, so it looks like my denominator is a 3x minus 2 and an x plus 4. And since I was dividing, I'm now going to change that division into a multiplication, which will put an x plus 4 in the numerator and an x minus 7 in the denominator. And I can now see that I have these identical x plus 4s. The x plus 4 divided by x plus 4 will give me a 1 as long as x is not equal to 4, but I'm about to take care of that anyway. And so I can multiply my numerators back together. I'm not going to do it with the boxes this time because we're running up close to 10 minutes on this video. So this is just going to give me a 2x squared minus 3x minus 14. And in the denominator, a 3x squared, let's see, minus 23x plus 14. And I have to come back to everything that was here, even the parts that I canceled. 3x minus 2 cannot be 0. X plus 4 cannot be 0. X minus 7 cannot be 0. So that one is going to tell me that x cannot be equal to 2/3. And x cannot be equal to -4. And x cannot be equal to 7. So with those included at the end, there is my final answer, and I've got my domain restrictions, my x values that I'm not allowed to use in there. And that should take care of it for that video.